Hello there, my friend. In this video I'm going to demonstrate how a CNC machine's G code functions will perform to machine the outside of this profile, the blue line, and I'll explain the basic functions of G codes and M codes and basically how a CNC runs on its simplest form. So what I'm going to do is imagine that's our stock material. I'm just going to get a cutter, 40mm in this case, and machine the outside. So I'll show you the code to do that and how it all works. Okay, so here's our program on the left hand side, just highlighted there. It's a pretty small program to do this, but it will perform all functions to do it, and I'll explain it to you now. So G code is supposed to be an ISO standard, however a lot of machine tool companies vary it slightly between one another, so you really need to get to know your own machine and how the G code functions on that. FANUC controllers will, the conversational controllers will produce their own G code, which looks like gibberish when you first look at it, but you begin to understand. But this has been written longhand by myself, and it is a very, very basic program, but it's got some key elements to explain to you how G code works. Alright, so at the beginning of the program for a FANUC controller, and HAS similar as well, we've got a number, or a letter O, sorry, followed by a number. Now what that block of code tells the machine is the program number, and the function of that is basically just to display in a program list so you can find what you're looking for. Now our next line of code will call up a tool and do a tool change. Now the CNC machine will execute one block at a time, step by step by step, but a lot of the newer machines actually read ahead so that it kind of buffers the program so it knows what it's going to do next, even though it's just executing one block at a time. Now our first line of code that the CNC is actually going to execute is T01 M06. Now what this does is, on some machines it will actually turn the tool carousel around to bring tool 01 or tool 1 in line with the spindle, ready for a tool change. So once it's done that, it will run the M06, which is an M code for a tool change. And what an M code does is, behind the scenes there will be a program that runs all the functions for a tool change that the operator doesn't really need to worry about. But when the machine reads the M06, it'll automatically execute that program to do a tool change. Our next line of code will set the spindle speed to 6000 RPM. That will be loaded into the memory of the machine, but again the spindle will not turn on until it reads an M code, which is MO3, to actually turn the spindle on. Now MO3 tells the machine to turn the spindle on at the designated speed in a clockwise direction. Now, MO4 is anti-clockwise. Now I'll just explain a little bit about my profile. The X and Y 0 is in the center of this square block with the radius overhanging out here. Now the block is 50mm wide by 50mm high with, I think, a 25mm radius. But from our X0, it's 25mm in the negative to the left hand side and 25mm in the positive to the right hand side. Now that'll come into play in a minute when I explain radius compensation. Okay, so currently at the moment we've got tool 1 in the spindle and we're doing 6,000 RPM with the spindle running in a clockwise direction. Now when you put the block of material in your vise or clamp it down or whatever, you're going to have to set a datum point, which is what I just showed you before, using the machine's software or whatever to set up an offset position, which is known as a job offset. Now along with that, when you set up your tool, the tool needs its tool offset set up as well in a tool file. Typically the two main information points that you need in your tool file for a particular tool is the radius of the cutter, so not the diameter of the cutter but the radius of the cutter that it actually cuts at, and also your height offset. So a lot of machines have probes and all this kind of stuff that you come down and touch, and that will give you a measurement to enter into your tool file, which will become your height offset. So now in this line of code, after our spindle's been turned on, we've got G00, G54, Z50, H1. Now I'll quickly talk about modal codes and non-modal codes. A modal code is a code that stays active until you either change it to a code that's in the same sort of family or cancel the code altogether. So an MO3 is modal because the spindle will be running until you tell it to stop or change speeds or whatever. So is a G0. Now G0 is a rapid move, and G54 tells the machine you're no longer working with your machine coordinates, which is normally the home position of the machine, but you're now working to the job offset coordinates, which you've entered into a job offset file. So it's saying rapid to the job offset to Z50. Z is up and down, Y is front and back, X is left and right. So it's going to rapid down to Z50, but it also calls on the height offset number 1, which goes with tool number 1 as well. So it will automatically calculate to position the base of the cutter at 50mm away from the top of your job. Now the next line of code is an MO8. That simply switches the coolant on. So an MO8 will switch the coolant on and an MO9 will switch it off. Pretty simple. So now we're going to move back to a G0 move, and we're going to rapid to X -50, Y -50, which now you know that I only want to machine this profile here. So how come I'm coming in at an angle like this and leaving at an angle as well? The reason is we call on cutter radius compensation later, and what you need to do is move to a distance suitably away in the two axes that you're calling radius compensation on, to allow the machine to adjust the cutter position automatically. So instead of being on the spindle center line like it will be here, as it moves to this point with cutter radius compensation on, it will automatically adjust using one of two codes, which I'll talk about in a minute. Okay, so now we've rapided to our X -50, Y -50. We're going to set the machine to feed down to Z -10, which in theory would take a 10mm cut being that the top of my job would be Z0, and I'm going to feed it down to -10. So that's what the G01 does. It switches the machine from rapid to a feed rate. Now, how does it know what kind of feed rate to use? We tell it right here. Now, the F quite obviously stands for feed rate, and we're using 2000 millimeters per minute. So whenever it is feeding, it will feed at a speed of 2000 millimeters per minute. So now, because the G01 is a modal code, the machine will stay in a feed rate until we tell it otherwise. So now our next line of code is G41. Now this is where it kind of gets a little confusing, but I'll show you a picture in a second. What G41 does is call on radius compensation that you've set in your tool file in the beginning when you set up your tool. So at the moment we've rapided down and positioned the cutter at X minus 50, Y minus 50, but that is on the center line of the spindle. So now what this does is it moves from that position to the side of our job calling on left hand radius compensation to our actual drawn dimensions. So when you get a drawing and it's got a profile, you only have to draw it as it is drawn, and the machine will calculate where it needs to position the cutter according to what code you tell it here. So we want to position the cutter on the left hand side of our profile in the direction that it's traveling. So if we wanted to position it on the right hand side of this, we'd have to use G42. G40 would position the center line of the cutter on the center line of the profile. We want to machine the outside, so we'll use left hand radius compensation and move it to the side of the job. While we're doing that, we're going to call up the radius offset number 1. Now it says D1, but it will actually call up the radius. So here's a nice little picture to demonstrate what I'm talking about. Here, let's say we wanted to use a drill to drill some holes around some random points. You wouldn't be using radius compensation, so you could use the code G40 to tell the machine, right, we're working from the center line of the spindle, and it will position the drill at the exact coordinate that you tell it. Now with G41, left hand compensation, the direction that it's traveling is the most important part of it. That's how it works out whether you need left or right hand. So on the pocket here, with G41 going in an anti-clockwise direction, we'd be positioning the cutter on the left hand side, and externally going around in a clockwise direction, we'd be positioning the cutter on the left hand side. Now the opposite is true for G42. If we're going around the pocket in a clockwise direction, we'd be positioning the cutter on the right hand side, and externally here, if we're going around anti-clockwise, we'd be positioning the cutter on the right hand side. It's always important when you're running a program that you've written by hand to run it in graphics or just above the job, so that you can get a clear idea that the side that you're calling cutter radius compensation on is correct. Okay, so now that we've moved to our position and called on left hand radius compensation, that is modal as well. So our feed rate's modal, our compensation's modal, calling up our diameter or radius offset is modal. So now all we need to do is tell it the next coordinate to go to, which is y positive 25, and now we're going to get into machining the radius. Now we're going to switch our modal G code from G01, the feed rate, to G02, which is an arc feed rate in a clockwise direction. G03 is an arc feed rate in an anti-clockwise direction. Now, before I click down onto this line, you'll notice that we have our endpoint. So X positive 25, Y positive 25, and now the I's and J's assist the machine to work out the center of the arc that is going to be performed. Now, they are incremental, and with each axis X, Y, and Z, you've got I, J, and K. I very rarely have used the K, which what they do is work in unison with each axis. So X and I work together, Y and J work together, and Z and K work together. So now the machine knows the start point, and when it reads this line of code, it will know the end point and the incremental position of the center of our radius. So the I's and J's are telling the machine from X and Y the incremental distance. Now, that is from your start position, which is where the white dot is at the moment. So incrementally in X, it's 25 millimeters to the center, and incrementally in Y, it's 0, because the cutter is already on the center line in Y. So around it goes. Now we go back to a feed rate down to Y negative 25. The next move says G40. Now what that does is cancel cutter radius compensation. So the previous line here, we had cutter radius compensation on. Now we want to move away from the job more than the radius of the cutter in X and Y to give it space to call off radius compensation. We do that by saying G40 X 50 Y negative 50, which will move away from the job, and the cutter will now be back on the center line of the spindle. Our next line, we wrap it up to Z50 above the job, and our next line is an M code, MO5. That will turn the spindle off. Now we can also add a line of code before we go rapiding too far, M09, which would switch the coolant off before we rapid up and get coolant all over ourselves. Now the next line, we are in a modal G0 mode, which is rapid. So what we're saying here is rapid to G53 Z0. Now on the majority of machines, that will rapid to Z0 using the machine's coordinate system. So G54, we're using the job offset system. G53, we're using the machine's coordinate system, which will rapid the tool or the spindle all the way home. Now that's modal as well, so we're still in rapid mode. We're using the machine's coordinate system, so we're going to send the table home in X and Y. Now the last line of code is an M30. And what an M30 does is it runs a program that's in the background, which is probably executing quite a lot of different little functions, like it will turn your spindle off, coolant off, all that kind of stuff. But it'll also reset the machine to default modal settings,
Some machines have switches that when you switch it on and it reads an M code, it'll turn the whole machine off. Basically, it ends the program and resets everything back to standard.